Good morning, good afternoon, everyone. Thank you so much for joining in. Today we have Dr. Stephen Laureys, who is a researcher at the Belgian Fund. Uh, he has written a book called Nonsense Meditation, and today he will be discussing the relationship between the brain and the act of meditation. So, Dr. Stephen Laureys, I'll just hand it over to you so you can take over.
Thank you, and welcome everybody to the Simply Neuroscience Synaptic Hack. I'm a neurologist talking to you from the University Hospital in Liège in Belgium, and I also direct a research unit here at university. That's the Giga Consciousness Unit, and also work in Canada at University of Laval at the Cerveau Brain Center. I know there's a lot of neuroscience people watching us today, so feel free to reach out if you have any questions or interested in collaborating in whatever topic that we'll be discussing today. I'm going to talk indeed about how meditation is good for your brain, which is kind of out of my comfort zone, really, because as a neurologist and during my medical studies, I never ever was taught anything about the benefits of meditation. So where I do come from, however, is basically the neurology of consciousness. So that's the title of an academic book about cognitive neuroscience and neuropathology, and how one of the biggest mysteries as neuroscientists is really trying to understand what is so important, our own human mind. And we do that here by, of course, working as a team. You see here a number of people who are all part of the Giga Consciousness Research Unit. And what they try every day is to understand, well, how it is possible that we're having this interaction right now. You're having thoughts, perceptions, emotions. And we have brain scans, of course, MRI, positron emission tomography, electroencephalography, transcranial magnetic stimulation, all technologies that permit us to do measurements. And yet we're not there. I think our ignorance is still enormous, and the challenge is so important because, of course, the knowledge that we generate as a clinical neurologist here will be translated to take better care of patients with damaged brains and impaired consciousness. So that's really our area of expertise. That's what we've been publishing about in the past 25 years. And in a nutshell, it helped us to identify neural networks. There's actually two. There's an external awareness network, which is active right now because you're seeing, hearing. So everything coming into your senses, you're conscious about that because of the dynamical interactions within that external awareness network. You see it's wide, it's making up the global neuronal network of frontotemporal parietal associative areas you see here colored in red. And then there's another important component to your consciousness, which we could call self-consciousness, the little voice talking to yourself right now, permitting you to do mental imagery, to anticipate the future, to learn from your own autobiographical past. And that is the internal awareness network. And that's colored here in blue. It's this midline core with the prefrontal, mesiofrontal, and anterior cingulate, and then the posterior cingulate and precuneus, very critical hub in this internal awareness network, where it's all about interactions between those billions of brain cells. And that is exactly what we'll be talking about when we look at all those different modified states of consciousness. And that goes from coma and chronic disorders of consciousness, all the way to concussion. And our team here has been studying champions, world champion boxing, Delphine Persoon, NHL ice hockey champion, Simon Gagné, again, using brain imaging to better understand how the very important organ, our brain, functions and goes through these extreme situations. We also look at pharmacological modifications, and that's anesthesia, which is a pharmacological coma, where we've been giving a number of drugs, propofol, but also ketamine, xenon, and that permits anesthesiologists to kind of put the brain switch to off. And when we here see the result of this is a positron emission tomography study, the brain's energy use, what we call metabolic activity, is going down by about half to its normal waking values. But there's much more, of course, to pharmacological coma. We also can look at how the brain is hallucinating when we give, for example, ketamine or other drugs, and not just by using positron emission tomography, by also using functional MRI, high density EEG, and even looking at very strange, extraordinary phenomena, such as near-death experiences. And again, I use the opportunity to ask for testimonies. If any of you know someone who had such a near-death experience, where classically you're thought to be unconscious because you had a cardiac arrest or a accident, whatever. But in contrast, your own subjective experience was very rich, and people afterwards tell us their memories. So share it with us. And we now have hundreds of testimonies, but we still need many more to understand this extraordinary phenomenon. And that's the email NDE from near death experience at uliege.be. And Charlotte Martial, you see her picture, is the person who's leading that line of research, where again, it is important as a scientist to remain humble. And sometimes we can be too arrogant and we think we understand everything about the brain and the mind. And that's very untrue. I never had a near-death experience, so I should be careful and listen to the people who had one. You see there a picture of myself with this high-density EEG net, and I'm about to receive psilocybin, magic mushrooms, to try and somehow get close to the experience, while, of course, the activity in my brain is measured. And I think that's very important, that we bridge what we call neurophenomenology, the subjective experience, with objective measures that we are now offered through all the brain scanners. In our hospital, for the past 25 years, we've also been using hypnosis. Hypnosis in a medical context. We have over 10,000 patients who had surgery, and that's, for example, thyroidectomy, so removing your thyroid gland, or mastectomy, removing a breast tumor, for example, while the patient is awake, lying on the operating table, thinking about pleasant autobiographical memories, a holiday, for example, and the surgeon is doing his job. It's very, very good illustration of how powerful your human mind is. And maybe we've been underestimating that, and at least in a medical context, not using its full potential. We also, again, with technology, use virtual reality here. You see collaboration with Encomfort, where you, as a patient, would hear and see basically a story that permits you to be dissociated, to be absorbed, to be less aware of what the surgeon is doing. And that's exactly what we see with our brain scans. It's that the external awareness network is disconnected, and the internal awareness network, this midline core, is more active. So understanding the power of the mind is what it's all about in our team, not just in pathological conditions, pharmacological conditions, also in hypnosis, as we just discussed, and trance. In Mongolia and many other so-called primitive cultures, you have these shamans who are using, for example, music, the repeated sound of drums, to induce an altered state of consciousness, a trance. And we had the opportunity to work with Corinne Sombrin, who is from France, an expert in the topic, and she wrote a wonderful book. It came out as a wonderful movie now. I invite you to see it. It's A Bigger World, in French, Monde Plus Grand, where actually our lab is in the movie, because we studied her brain and we studied these people during trance and how the activity in the brain permits you to again be disconnected, absorbed in a modified state of consciousness, which I think is truly wonderful. We also have artists. We're studying creativity. We're understanding, trying to how, for example, my friend Alain Altinoglu, who is the director of the Brussels Opera, well, what is happening in his brain when he's listening to music, his favorite piece of Beethoven, and when he's imagining that piece, when there's complete silence, but in his head, you see, there's like firework. We see here the result of a high density EEG connectivity study. And you see these threads, the lines illustrating the interaction, the connectivity in the brain. And the more threads, the more connectivity, and the more red, the more active. And we see that the brain has this incredible potential to recreate, in this case, classical music. And that is, I think, something also important to each and every one of us. As a scientist, of course, creativity is terribly important, and how we can get into that kind of mental flow. We had world champions, athletes like Guillaume Néry, who is the only living human who went down in apnea to minus 139 meters. And he again came to the lab holding his breath for 7-8 minutes while we were measuring with fMRI, or as you see in the picture, high density EEG, what's happening in there when there's no breathing. How can the brain function during prolonged apnea? And again, trying to couple that to what he's experiencing during these defeats. And he is definitely, again, in an altered state of consciousness. It seems that that's what we've shown, and it's about to come out as a scientific paper. This is close to the meditative state. We also, thanks to international collaborations within the European Space Agency, we're studying the brains of astronauts. So as you know, there's 7 people up there now in the International Space Station. And before they take off, we would put them in the MRI scan. And when they come back after sometimes a couple of months, or as is the case for Gennady Padalka, who's the record holder, 878 days up there, clearly your body and brain needs to adapt to zero gravity, and again needs to adapt when it comes back to the Earth's gravitational field. And there's many things we don't understand about that. It's also a good illustration of how the brain can function as a team. The other 6 guys up there and cope with isolation, stress, sometimes emergencies and self-control, as you can see in Canadian astronaut David Saint-Jacques, who's meditating up there, 408 kilometers above our heads. Thomas Pesquet is the French astronaut. He's currently up there, and he's actually holding the diffusion tensor image of his own brain that we study here with the colleagues. And it's, again, wonderful to do and to publish and to push the boundaries of human knowledge by studying these wonderful astronauts and cosmonauts. And it all comes down to understanding what makes the brain unique, and that is its connections. And the first to see that was Ramon y Cajal. You see him here peering down his microscope. He would receive the Nobel Prize a couple of years later. And the drawing here is the first ever drawing of a neuron. You see those branches that you, of course, know, the dendrites, the axons, and the dots are the synapses. So it's not just your brain and the billions of neurons, it is the thousands of billions of brain connections, of synapses. So that is in permanent change. And if you will remember anything about this webinar, it will actually change those brain connections. But today, we will be talking about meditation. As said, it's out of my comfort zone, and it's actually a meeting I would have in 2013 during a TEDx talk in Paris, where I was talking about brain and consciousness, and Mathieu Ricard, who's a Buddhist monk, but also a PhD in biological molecular biology from the Institut Pasteur in Paris, he was talking about meditation. And somehow we became friends, and he invited me to go for a retreat, which was a wonderful experience for me. And I invited him to come to our lab as a guinea pig. And that's what you see on the cover of the French version. The book is now translated in 9 languages, and the English copy you see here, it's called the No Nonsense Meditation Book, A Scientist's Guide to the Power of Meditation, where I try to summarize what we know about the scientific studies, but also the clinical translation. And I now prescribe meditation as a neurologist here at the academic hospital in Liège. But it's an easy read. It's a popular book where I also tell my own personal story. And I think that my main message is do what you can. Don't put the bar too high. I think meditation just stands for mental gymnastics. And there's many, many ways to do this. But it's extremely powerful. And we can, again, learn from the extremes. I was showing you what we do with these top athletes and astronauts and world champions. If you look at meditation, and we know this iconic picture from this Buddhist monk who puts himself in fire as a protest in Vietnam, and he doesn't move an inch. While if we just burn a finger, it's terribly painful. So how is it possible? How can we control or learn to control our mental activity in such extreme settings? And that's what we've been doing now the past 5-6 years, working together with, again, the experts. And I think Buddhist monks are truly experts when it comes to the study of the mind. And it's fascinating to discuss this topic with them. On the picture, you see my good friend, Lama Zopa. And you see, again, he is wearing this EEG cap during meditation, trying to collaborate, and this is really a dialogue between scientists and experts in, let's call this, contemplative practices. And that's very complementary to what my main job is as a neurologist. I trained to prescribe pills or interventions, and it's wonderful we have all that top medical knowledge and technology, but it's not the only thing. And I see now how many of us struggle to find meaning, to cope with the challenges during our studies, during our professional life. I see a lot of people coming to my consultation with burnout, but also with symptoms and complaints. Insomnia, they can't sleep because they're worrying too much. They're anxious, they're depressed, they have chronic pain, headaches. There's basically no symptom in medicine that will not be more pronounced when exposed to chronic stress. So for ourselves, for our interaction with others, clearly it's not just the neuropharmacology. And that's what I discovered, and that's what I would like to share with you today in this wonderful webinar series, where this is a picture of the book. I show you the number of scientific articles. You can just check this in Medline PubMed since the 70s all the way up to today. And you see that the past 20 years, there's like an explosion in the number of articles on meditation in black, or mindfulness, which is currently the form of meditation that is the most scientifically studied. We see it's really going exponential. Just last year, 1,800 scientific articles. So when I defended my PhD, that was in 2000, on the brain and coma and consciousness, a journalist asked me, Professor Laureys, what do you think about mindfulness? So I checked Medline, and I wasn't convinced. And you see here in gray, 2000, there wasn't so much scientific evidence. But since then, a lot has changed. And that has changed my own personal view, my own personal experience, but of course also the work here in the lab, where we now have a very active line of research on the power of the mind, on the study of meditation. And again, you're very welcome to join and to send us an email if you have any question or want to collaborate in any way. A key person was Mathieu Ricard. This is the picture taken the first time we met in Paris at the TEDx. And soon after, he would come as a guinea pig and go through all our possible measures of brain structure, brain function, of course, using the MRI, predicting us to, that's what we do as scientists, objectively measure. So he's 70 years plus, and his brain, if we measure it, biologically speaking, would be 10, 15 years younger. He has less atrophy than his peers of 70 plus. And more specifically, in areas he has been training. I highlight them here in this picture. Again, it's out of the No Nonsense Meditation book. If you're interested, you can find the details and the references. But you see the hippocampus in red. As you know, very important in memory. And it is just bigger when we do voxel-based morphometry, when we measure these structures, as is the anterior insula in blue, important for self-regulation. The anterior cingulate cortex in green, very important in attention regulation. It is bigger when you measure volume in people who do a lot of meditation. But it's not just about training your attention. It's important, but you also can train emotional control. And there you see the left prefrontal cortex in yellow. And again, this structure is just increased in volume, but also increased in structural connectivity, which is what you see here. Diffusion tensor imaging permits us to look at those thousands of billions of brain connections, the big high roads in the brain. You see the colors represent the orientation. And like red is here, the left to right connections. So when you do a lot of meditation, you have increased connectivity within attentional networks, within emotional regulation networks, but also overall between your left and right hemispheres through the corpus callosum. That is what we saw in experts like Mathieu Ricard, the Buddhist monk, translator of the Dalai Lama, and in many others who followed after him. And I'm very grateful to Mathieu that he lends his brain and body and time for scientific exploration, where here we put him in a PET scan, positron emission tomography, permitting us to measure the brain's energy use. Your brain right now is using more energy than any other body in your, any other organ in your body for its weight. And when we inject radioactive glucose, we see, you see here in red and yellow, how this metabolic activity is in people like Mathieu and in others, where it has been shown that meditation has a positive impact on the normal aging and the decrease of metabolic activity. Actually, as soon as you hit 40, and I'm past that, your brain energy use is no longer increasing. That's a euphemism. It's going down when you go older, and meditation can positively impact that. And there's now European studies, and Liège is participating in that, where we're proposing meditation and mindfulness to people who are at risk for degenerative dementia. Now, of course, meditation will not, you shouldn't see this as a vaccine or a cure for Alzheimer's disease, but definitely we can offer something to patients in addition to the pharmacological care, and currently that is limited. And I think it's very important that we empower patients and give them a more active role. So meditation is, for me, just mental training. Training your thoughts, perceptions, and emotions. And what we do with scientists, and what you see in the picture, is trying to understand that process by all possible means. In this case, putting high density 256 electrodes, while Mathieu Ricard is, in this case, actually doing nothing. He's just sitting there. And this is looking at the default activity. And your brain can't help it when it's just so-called resting. It's thinking. It is having perceptions. It is having emotions. And that is what we see here. We see high connectivity. And when he would meditate, he would not go flatline. Meditation is not about thinking of nothing. Meditation is an active process. And I think it's very clear here. You see an increase in functional connectivity. More connections, more efficiency, more red. The only time actually your brain really goes flatline, that's what we study also with the team here, the Coma Science Group, is when you are in brain death. So meditation is an active process, it's mental gymnastics, and it permits basically when you do these attention, for example, attention to an object or to your own breathing, you would go through this loop where you focus and then your attention wanders. You will notice that distraction, refocus, keep your attention, and you have this continuous loop. So classically, you would do this in a formal meditation, breathing meditation, but it can be also attention to a mantra in your head, which is transcendental meditation, for example, or focusing on an object, or just focusing on what's coming into your senses. You would go through this cycle over and over and over again. And then just as you can train your muscles in the gym, you will see that there is a structural and functional change in the brain. And that's exactly what we've seen in the experts, the Buddhist monks. But you don't need to be a Buddhist monk. Anyone, and that has been shown, who would start an 8-week course of mindfulness-based stress reduction would also, when we use these brain scans, show visible effects. And you can do that, as said, through formal meditation. And you see me here sitting in the classical, not full lotus, but an attempt. And that's one way to do it. And you can sit down for a couple of minutes. I'm just back from a retreat with my good friend Lama Zopa, where we meditated for, what was it, 4 hours a day, 5 days in a row. And that's interesting, but it is not the only way to do meditation. So sitting here formally is one type of exercise, but at one point you need to stand up. You need to come back from your retreat. You have work to do. You have your studies to accomplish. And so that's really when I think the added value of meditation kicks in, to try and implement it in the rest of your day, of your week. And that can be done in many, many ways. But I'm not a Zen master. Maybe I should just shut up and permit to learn from the experts again. And this is my youngest son. I've got 5 kids. My youngest son is now 3. And I took this video in the middle of the lockdown. I'm not sure you will hear the sounds, but you will see him just breathe. And that is the most basic exercise. If a 3-year-old can do it, anyone can do it. If I can do it with my nervous personality and as a control freak, I think anyone can just take a breath. It's not always like that, but when you do these attention, breathing meditation exercise, really you would see a change in the internal awareness network you see. It's all about focusing your attention. So meditation is mental gymnastics, learning to become more aware of what's going on inside about thought, perceptions, and emotions. And you soon realize that you've got kind of this monkey mind. You have these thoughts and perceptions and emotions, this continuous stream of consciousness going on and on and on. Right now, you have this little voice talking to yourself. And that's wonderful, that's powerful, but it can also be too much and make us anxious, keeping us from falling asleep in the evening. And one way to show this monkey mind, and what I would do with Mathieu Ricard when before COVID we could go and give lectures together, is put an EEG monitor. This is the neurosteer system. You see 3 electrodes on his head, and he would be in front of an audience, 2,000-3,000 people, and inviting them to do the meditation with him. And I can then, thanks to this EEG monitoring system, show what's going on in terms of the electrical activity in his brain, in his mind. And you would see there's time. So this goes on the x-axis. And then you have a decomposition, like hundreds of different components of the EEG activity that reflects general arousal, focused attention, emotions, executive function. So every line is one of those components, and it would jump from one to the other, red and blue and green. And this is exactly what we call the monkey mind. Your brain creating this continuous stream of consciousness that goes on and jumps from one to the other. And then he would start meditation, and you would see something very different. And these are not lab conditions. He's standing in front of an audience, 3,000 people. But as soon as he meditates, you see there's this stability. And then again, he ends the meditation. And what you see here is that like sports, I think we can compare meditation to sports. If you say I do sports, well, you need to be more precise. Are you running and you will get strong legs? Are you swimming? You will get strong shoulders. Meditation can stand for a number of exercises. And we see in the second meditation exercise, he's doing his favorite, loving kindness, training compassion. And you see, again, the stability, but it's different colors. It's different parts of the brain that show activity. So one is about focused attention, focusing your attention to the breathing. The other is taking a mindful walk. It's open presence. It's being attentive to what's coming into your senses. And again, we can learn from kids. When I take a walk with one of the kids, they are, again, little Zen masters. I would be walking very often on my cell phone, making a call to the hospital or sending a text, or even when I'm not holding my phone, my thoughts would be elsewhere. When my son, Louis, is walking, the 3-year-old, he's really there and only there. And he would see something on the ground and all the attention would be there. And that's another way to exercise meditation, monotask. So we can just do this exercise. The next time you go for a walk in the park or in the woods, enjoy for a couple of moments what you see. What do you see really? The greens, shadows, the light, what you feel, the sun on your skin, little breeze of wind, smells. So these are simple exercises, but an invitation to train those different cognitive processes. And then, of course, you can also be attentive to your emotions. We're not robots. Emotions are part of our humanity. And very often, that's what I see in my consultation as a neurologist, we can get into trouble. We can lose ourselves in emotions because maybe we never actually learned how to deal with them. And I think in our educational system, I don't know about you, share it and put it in the chat, but very often educational system is about knowledge. And we are acquiring knowledge, which is very important, but it's not the only thing. And I think we need to invest more in what makes us different from computers. We are part of the Human Brain Project. We have these supercomputers. We talk about artificial intelligence. We would use that. It's very useful also for us as scientists. But we are not functioning the way a supercomputer or whatever PC is functioning. Our brain is not digital. Our brain actually, and our body, and as human beings, well, we have real perceptions and emotions, and this is incredible. We can have creativity, we can have motivation, we also can have frustration. And so just learning to appreciate that. Don't expect the sun to be there 24/7. Sometimes there's clouds, there's even storms, or it can rain, and there can be lightning. And this is an exercise, again, that I would, when I am in front of children, and my wife is a psychologist teaching mindfulness to kids, so we'd really train young people to answer the question, how are you? How are you really? And that permits you then to be more attentive to how the other is and feels, which I believe is terribly important, and it's part of what we call emotional intelligence, that is, I believe, not receiving enough attention in the educational system. So if, again, you look at brain scans, you would see their specific activity in the emotional networks when, for example, you would train empathy, compassion, loving kindness meditation. The picture, by the way, is from my daughter, Clara. It's a couple of years ago. Now she's 22, studying at university, and again, also using meditation to deal sometimes with the challenges of life. Back to our super guinea pig, Mathieu Ricard. You see him here again in our lab, where we do not only fMRI and PET and EEG, but also TMS. TMS here, while simultaneously recording EEG. This is done together with our colleagues in Madison, Wisconsin. You saw I started with the book, The Neurology of Consciousness, where Giulio Tononi is a co-editor, and he came up with integrated information theory. It's one of the theories I think very interesting on how to understand consciousness, where the theory holds that the information needs to be integrated, and we can put mathematical equations behind what is information, what is integration, and then again confront it to clinical measures. That's what we do with what we called perturbational complexity index. You can find the papers on our website if you would Google me. And when we did this in Mathieu Ricard, we saw something never ever observed before, because we developed this test to basically better understand consciousness, actually unconsciousness in coma patients. Remember, when there's important brain damage, you would hit their brain, their gray matter, with the TMS, measure the electrical echo with the EEG, and we would see that there would be a lack of information or integration, and this we can call it level of complexity induced by the perturbation would be very low when you are comatose or anesthetized, and it would be high when you are in a locked-in syndrome, or when you're minimally conscious, or when you awaken from anesthesia, or we also studied sleep, you're in REM sleep, dreaming. But this is a very robust measure that basically none of the volunteers, we studied 100 together with our colleagues from Milano and Marcello Massimini's team, and you can't voluntarily influence the measure until Buddhist monks showed that it actually can be done. And that's what we published. They can voluntarily increase or decrease complexity in the brain to a TMS, stereotactic perturbation, which is what you see on the screen. The little asterisk is where in the gray matter we are hitting, perturbing his gray matter. And that's wonderful about people like Mathieu. He has been traveling the world, not just working with our lab, but also colleagues, Richard Davidson in Madison, France, the study I mentioned about the effect of aging, effect on empathy and compassion with Tanja Singer in Max Planck in Germany. So these are just a couple of papers where he is not just a participant, but also a co-author, as said, with his PhD in science. So very important to take home today that the effect of meditation can be as big as the effect of medication, of anxiolytics, of antidepressants, of analgesics. So important for those of you who one day maybe see patients to more exploit the power of the mind, and meditation, I believe, is a good example of that. And we've seen how studies now show that it changes the brain, the body, actually also the immune response, and even at the level of the DNA, chromosomes, we can see that meditation can have an impact. And that's, again, a picture from the book. You see here your chromosomes. You know, you have these telomeres that will protect your DNA. Every time the cell divides, it will get a bit shorter. Turns out to be that when you're stressed, this process is being enhanced, and when you meditate, you can again have a positive impact on this natural effect that we see during aging, telomeres, and especially telomerase having a measurable change in people who do meditation. So I hope I've shown you some evidence, and I will close here to permit you to ask your questions, that meditation is something I think that should be part of our lifestyle. It is as important as taking care of your physical health, as taking care of your good quality sleep, good quality food, social contacts. Well, meditation for me is something that is as important, can and should be done at any age and also at any place. Thanks to Mathieu Ricard, I had the chance to meet a couple of times the Dalai Lama. This was in Strasbourg University in 2016, where at the Faculty of Medicine, meditation has become part of the curriculum, and I think that is an example to follow. I think that should be the case in all medical schools and actually in all schools, because it is too important to be ignored. So different ways to enjoy it: focused attention, just orient your attention to your breathing, or open presence, or compassion, basically training the different brain networks, thoughts, internal awareness, perceptions, external awareness, and then the emotional networks as discussed. In the book, you will find many testimonies. This is an example from David Lynch, who's a big advocate of transcendental meditation, but there's many ways to enjoy it. Also, we can learn from kids, and the way you eat chocolate ice cream, for example, can also be an exercise in meditation, and it can be done formally but also informally. And that's what I would do here at the hospital between two patients. Just take a breath and keep my attention to the breathing. If I do that, my blood pressure would go down, my heart rate would go down, my stress hormones would go down. And you can do that while commuting, in the train, in the bus, in a break during your studies. And I'm very happy that you were here today with us. And if you got any questions about the study of the mind, the impact of meditation, or all the other stuff we're doing here with the team, don't hesitate to come back to us or share it through the social media. We are very happy to collaborate with our friends from all over the world, being it with the lab in Europe, Belgium, or in Quebec, Canada. Thank you so much, and that leaves us time for some questions. So back to the moderator.
Wow, that was really insightful, Dr. Stephen. So we're still waiting on the questions from the chat, but then I have some questions, because I come from a background in which meditation is really encouraged to be incorporated. They really encourage to incorporate meditation into your daily lifestyle. And this makes me curious. Like you mentioned that some of those monks which you studied and investigated, their brains had atrophied much lesser, and it was actually 15 years younger. So does that like correlate with greater neuroplasticity?
Yes, absolutely. Thanks for asking that. So we've been studying neuroplasticity for the past 25 years now in the damaged brain, and how it recovers after trauma, concussion, but also cardiac arrest, and in the other examples we gave in these athletes, astronauts, and so on and so forth. So absolutely, I think meditation is just a wonderful exercise in neural plasticity. And you're absolutely right. We have here colleagues. We have Raja Panda, who is from India doing his PhD here. And it's wonderful to see how in your culture it is really part of your daily experience, and I think we can learn from that. But it's universal. I am raised as a Christian, and I see in all big religions, not just Buddhism, Hinduism, but there's also in the Catholic Christian tradition this contemplatives. We have in the Muslim world the Jewish dancers, also a kind of meditative practice. So I believe this is a universal need, and we're very happy to again learn from your experience.
Yeah, and there's so many questions regarding meditation, like what is the right time to do meditation? Because some people say that meditation happens best during early mornings. And do you have an opinion on that? Of is meditation sort of like something that you can do at any point of time, or are there specific hours of the day in which it also like go goes hand in hand with your body's rhythm, circadian rhythm?
Yes, you're absolutely right that if you can make this a habit, and if you can every morning take some time to do your favorite meditation exercise, or every evening, that's wonderful. But I think we also need to see what is possible at any given moment in life, and there's different phases. As I mentioned, I have 5 kids, um, married, the job in the hospital, at the university. Sometimes, to be honest, at our home in the morning, it's just chaos, and I cannot find my 10 minutes or 20 minutes or whatever. It's just running from one activity to the other. And there, I think it is good to maybe not be too harsh with yourself, to not put the bar too high. And if you can make this into a daily habit and do it every morning, wonderful. But some other people would maybe fit it elsewhere in their agenda. And as said, I think that that's wonderful that you can do it basically while waiting in the grocery store, to go to the cashier. So there's many ways to do it. You can do it while doing your sport. You can do it while listening to music. So do what you can is really my basic advice. And in the book, I give a number of very simple exercises where you also can maybe enjoy, for those like myself who like to maybe change practice. And then it's kind of like going to the restaurant or to the sushi bar. You just have different things on the menu. You try them, you like them, you take more. You don't like it, maybe you will come back and try it later. But it's this personal experience, this personal journey, which is of course very different from me prescribing a pill. That's easier. Here it's really this exercise, to try these things out, and that's also why I like the 8 weeks mindfulness-based stress reduction program so much, because it gives you a little taste of the different exercises.
Right. Yeah. So it's more like a tool to increase your quality of life and perception.
Well, it can be many. It depends on your own personal needs. It depends. If you are, struggling to focus, it can help you. If you're struggling to find sleep, um, it really depends. And it is, of course, much more than something that helps you to reduce stress. It's terribly interesting, and it's now part also of the medical guidelines. When you are suffering from hypertension, for example, of course there's the drugs, but we know that stress will increase blood pressure. So meditation now is offered there, but it can be so much more. And that's why also, when discussing this with David Lynch, the famous film director, it helps him, and you can read about it in the book, in enhancing his creativity, and getting in this flow where, sometimes things just come. When I'm working on an article, just everything goes easily, and sometimes it doesn't. And meditation again is one way to help you to find your focus.
Right. And in the future, do you think that meditation can be a full alternative to the current invasive and non-invasive methods of treating psychiatric disorders based
So
on the
I,
current course of research?
yes, well, it's a challenge, right? And I started out saying that consciousness and our mental experience is one of the biggest mysteries. We shouldn't be too arrogant. Um, I see this as very complementary, and I'm very happy we have the knowledge and the medications to treat the whole wide array of neuropsychiatric diseases. But then there's more. There's not, as said, only the pharmacological interventions or neurosurgeries, or what we also do is electrical stimulation of the brain, invasively, non-invasively, called TDCS. Um, but exercises like meditation offer you to take a more active role and to, as said, positively influence um, both the course in these diseases, and then of course we don't need to wait before we're sick. I think this is a major role to play in preventive medicine, which I believe in Europe and the States receive not enough attention. So I'm convinced we'll see more and more of this. It's a challenge because, of course, um, when money is involved and the pharmaceutical industry, I'm still a bit disappointed that when I go to conferences, well, it's a lot about drugs and pharmaceutical companies sponsoring these events, and I hope we'll see more about meditation in the future, but it's just a question of when is it going to happen, because we have no choice. It's too important for us not to pay attention to this.
Yeah, and looking at the trend of the number of scientific articles on meditation, which you presented, it looks like the world is taking a focus towards this field. Uh, as another question that we have is about its relationship with sleep. Does meditation help reduce the need of sleep in any way, and how does it affect like our dreams, and has that been like a area of study?
Well, it's again, we would need to specify what type of meditation are we talking about, and there's a number of very interesting, fascinating studies on the influence and interaction between meditation and sleep. But it would depend: are we doing transcendental meditation? Are we doing the kind of breathing meditation? Is the effect about insomnia and people who have difficulties to fall asleep because they're just too stressed out, and this little internal voice is turning like crazy? Or are we seeing this as a way, indeed, as you asked, maybe influence the number of hours of sleep we require? So I think it's still early days, and we need to separate: do we see this as a medical tool, and then we need to be very specific about what indications, in this case sleep pathology, and what possible contraindications, side effects, and so on and so forth can we expect, and do this in controlled randomized studies, which is currently being done, but there's still a long way to go? Or do we see this as something we can all enjoy out of sickness, being brain or body? And also an interesting link about meditation is sleep is its effect on lucid dreaming. So lucid dreaming, as you know, is the possibility that during REM sleep you suddenly become aware that you are dreaming, and that is also something that you can train, and where studies have shown a very interesting interaction, where I see just fascinating research, for example, at the University of Madison, Wisconsin.
Right. Dr. Stephen, one of our participants wants to unmute and ask you a question. So,
Pleasure.
yeah, Dava, you can go ahead.
Thank you. Can you hear me?
Yes.
Okay, thank you. Hi, doctor. Hi, Dr. Stephen. And hi, guys. So my question is about so you talked about like Matthew Ricard and the work that Richard Davison, and also I did some like so I did an undergrad paper and like about this meditation and stuff. So like one thing that really stuck with me is like, is there a different level of consciousness that meditators like are in, I mean, a different level of frequency than ours, like people who don't do meditation? Because like in terms of emotionally coping up with given stimuli or stressor, they're far more better than like people who don't meditate, right? And I'm just wondering, is there a different level of like consciousness where they can actually interpret the world a little bit different than the people who don't meditate? If that makes sense.
Yes, thank you, Dava, for this question. It's a very good and difficult question. So we would need to define, of course, what do we mean by consciousness and those different states. And you mentioned your own research, and I think we're also collaborating with Professor Bindu Kuti from the Center of Consciousness Study in Bangalore, India, and the National Institute of Mental Health and Neuroscience, where I think fascinating research is being done. It's very interesting for me to listen to you guys with your background and your expertise, people like Sadhguru, also with my good friends at Harvard, collaborating again to try and answer your question, which is a difficult one and a tough one. And maybe we shouldn't be too reductionist and see, meditation and its impact on some form of consciousness as being simply related to this or that frequency band. The brain is, of course, very complex, and it's about the dynamical interaction of these very diverse brain regions changing all the time. So I think really we need you guys. We need more young, brilliant minds to help us answer your fascinating question, where I think we're just in the beginning.
Thank you so much, Dr. Stephen. Yeah, thank you so much, Dr. Stephen. It was a very good talk, and we'll all try to take a step back and meditate once in a while. Thank you for joining us.
Thank you. Wonderful closure, and happy to join next year. Great initiative. Take care.